till now what we have seen is the general operations in Gambit available, like move copy operations. We have also seen the GUI of Gambit, and in last lecture we have seen something related to the virtual geometry. Now in this lecture we are going to have a look at geometry creation operations available in Gambit. So we'll start with the vertex creation and then edge, face and volume creation. So let's start. So there are two main approaches available in Gambit for geometry creation, which both the approaches uses ACIS geometry engine or geometric kernel. There are two approaches, as I said. One is bottom up approach and other is called as top to bottom approach or top to down approach. In bottom up approach, what we do is we start with the basic entity, the lowest order entity, which is vertex in case of Gambit. So there are a lot of operations involved or available to create the vertex. Like you can create a vertex from coordinate, you can snap the vertex to a grid, or you can create a vertex on an edge. So those kind of operations are available in Gambit. As I said, there are different operations to create vertex using coordinates or grid snap or something. Similarly, there are edge creation operations, like you can create a straight edge or you can revolve the vertex to create the edge, you can create the arc and all. Then face creation and then volume creation. We are going to have a look at in detail all these operations. So this is bottom up approach. It means if you want to create a cube, for example, you start with the vertices, then you connect the vertices by using a straight line, then you create a face by using wireframe, and then you create a volume by using faces. So that is nothing but bottom up approach. We also use a top to bottom approach or top down approach. In that, what we do is we create the faces or volumes directly, but those things are only a primitive kind of geometries. Like face creation, generally you can create a rectangle directly by giving height and width. Similarly, you can create a circle by giving radius and the origin, or you can create ellipse. If you talk about volume, you can create directly brick, cylinder or sphere, etc. Now once, for example, a brick is created, you have to give the height, width and depth of the brick. Once that is given, automatically internally Gambit will create necessary vertices, edges and faces. It means once the cube is created, those geometries like faces, edges and vertices are available to you. Now you can build your geometry on top of that. So that is called as top to bottom approach. We start with the topmost entity, volume or face, and then we extract the lower order entity and then we work on the lower order entity. If you talk about typical geometry creation operations, it involves both. It means sometimes you use bottom to top and sometimes you use top to bottom. Now let's have a look at the vertex creation or vertex operations in detail. So this is the overview of how you can create vertices. There are different methods of creating vertices. You can create vertices by giving xyz coordinates or r theta z or r theta and phi. I mean, that is nothing but in cylindrical, spherical or Cartesian coordinates you can create vertices. You can create vertex on edge. It means one edge is available. You can say that, okay, I want to create a vertex at the 50% from the start point or 20% of the start point. You can create a vertex at the intersection of the two edges. You can create a vertex at the centroid of edge, face or volume, or even if the one vertex is available, you can create a new vertex by projecting it on a given edge. So these operations are available here. So if you go to geometry, this is the geometry toolpad. If you go to geometry, the first button is a vertex creation command button. So these are the operations available on vertex. These are the different operations available on vertex. So the first operation is nothing but create vertex. So as I said, you can create vertex by using different methods, from coordinate, on edge, on face, on volume, at intersection, at centroid, and project given vertex on an edge. So these are the operations available to create vertex. So first operation is nothing but from coordinate. So from coordinate means it will create a real vertex. So it is nothing but create real vertex, because real vertex is nothing but a vertex which has its own xyz coordinates. So once you are given the coordinates, for example, if I give 0 0 0, when I say apply, a vertex is created. If you see here, it is in white color because it is standalone vertex. Or I can say, okay, give me a new vertex at 10 0 0, apply. If you do a fit to screen, now you got the two vertices. this is at 0 0 0, this is at 0 10 0 0. Similarly, you can say give me a vertex at 10 10 0, fit to screen. I got third vertex, and again I can say 0 10 0, apply. I got one more vertex. So these are the 4 vertices which are created by giving the coordinates. This local and global is nothing but if you have created, for example, I will go and create one more coordinate system. For example, go to tools, create coordinate system, use a method called as offset, and let's say I want offset is equal to 10 x. The new coordinate system should be at x is equal to 10. So I got new coordinate system. Now if I go and create a vertex, if I give a value of coordinate, local coordinate, let's say 10 0 0, it means that is related to the coordinate system right now which is active, and right now you can see that this is active because this is in green color and this is in white color. So coordinate system 2 is active. What Gambit does is automatically whatever the coordinates you are going to give, it automatically maps that to the global coordinate system. It means if I give something like 40 here, it will, or 49, it will update it at to a 59. So if I say 10 0 0 in a local coordinate system, in global coordinate system it is 20 0 0 because your local coordinate system is present at delta x is equal to 10. So if I say apply, I got one more vertex which is here, or if I again say 10 apply, I got one more vertex here. So this is the way this local and global will work. You can at any point of time you can always activate the coordinate system you want. Now coordinate system 1 is active. If you see here, now whatever the values I am going to give, those values are with respect to the first coordinate system. So this is the way it will work. So this is nothing but creating a vertex by giving coordinates. While giving the coordinates, you can also activate, okay, I want to give, I know the coordinates, my geometry is cylindrical geometry, so I know the coordinates in r, theta, z. Once you give this r, theta, z, then what it will do is, it will map it to the global coordinate system which is x, y, z. So for example, if I am giving r is equal to 180, r is equal to 10, theta is equal to, let's say, 90, then what it has done is it has mapped it to the 10 10 0. So this is the way the cylindrical will work. Similarly, in spherical coordinate system, which is generally used for spherical geometries, you need to give r, theta and phi. Once you give r, theta and phi, it will directly map it to the global x, y, z, and then it will create the coordinate. So this is nothing but this is the method of creating vertices by giving coordinates. The second method is on edge. So let me create some edges for our reference. So I will use this vertex, then this vertex, create the edge, this vertex, create the edge, this and this, create the edge, then this vertex and this vertex, create the edge. So go to pick mode, right click, keep on pressing it, then left click, you will go to pick mode. So select the vertex or vertices, first vertex and second vertex, because this needs 2 vertices, and then you can say apply somewhere here, or you can say right click is nothing but apply if you are in a pick mode. So again this vertex, right click, pick this vertex and this vertex and right click, apply, and go in normal mode. This you are in a pick mode, go in normal mode, again the same process, right click, keep on pressing it, and then left click. So this is nothing but normal mode. Now we have edges right now, so I can create a vertex on an edge. So if you go to the second method of creating vertices, that is nothing but on edge, what it will ask you is, it will ask you which edge you want to create the vertex. So go to pick mode, and select the edge. So I want to create a vertex on an edge, so you select the edge. For example, I go into pick mode, I select this edge. Now whenever I select, wherever I am clicking, that point Gambit has taken. So if you say this is 0.4616 something, and that is nothing but something like 46% from the start point. So whenever you select the edge, you see that there is a direction. So this is actually a start point and this is the end point of the edge, and this is the direction. How this is like why this direction is fixed, because at the time of creation of a edge we have selected this vertex first and then this vertex. That is why the direction is from the start vertex to the end vertex. Now what I can do is I can always drag this at another location. So again the procedure is, you select the edge. If you are not happy with the location, then you just middle click keep on pressing middle click and drag, so it will change the position. So now what it does is you are giving how much percentage, like in terms of non-dimensional, you can say length. 0 is the start point and end is the 1 is the end point. Now you are going to give how much percentage or how much u value, that is called as u value. U is 0 at the start and u is equal to 1 at the end. You give here u value, for example if I give 0.5, it will be exactly at the center of the center of the edge. So whenever I am going to give this value, automatically Gambit has information about this edge, so it is going to calculate the xyz coordinates. So that is what Gambit does. So if I say apply, then I got a new vertex which is nothing but this, and the one point to remember here is this vertex is not part of this edge, in the sense this edge is not splitted using the vertex, this created vertex. So standalone vertex, it is nothing to do with the edge. Only thing which it has done is at the time of creation it has used as edge definition to just calculate xyz. Once it calculates xyz, the vertex will be created and it will be a standalone vertex. It has nothing to do with the edge. That is for real vertex. Now if you talk about virtual vertex, then virtual vertex is like, it's like a parasite entity. What it does is, again same information need to be given, at what length or at what u value it is located, it will have xyz. If I say apply, it is a virtual vertex. But virtual vertex in the sense, this vertex doesn't have its own definition. What it does, it always relies on the underlying geometry. So in this case it relies on the edge. So I cannot delete this edge unless and until I delete the vertex, because this edge is acting as a host for this guest entity, which is nothing but a vertex. So I cannot kill host if there are some guests. So that is the funda. So one I can always do, like I can create a virtual vertex on a edge or real vertex on a edge. So you just give a value, u value, you select what type of vertex you want, and then you say apply. Automatically Gambit will calculate its xyz coordinate and it will create a real vertex if I activated real vertex, or if you it will create a virtual vertex if I activated virtual vertex. In case of a virtual vertex, you cannot delete this edge unless and until you delete this vertex, because this edge is hosting one particular entity which is vertex. So this is create vertex on a edge. The third method is nothing but create vertex on a face. Similarly, so let me create a face for our reference. So I will go and face creation, wireframe, as I already have a wireframe. So I will select this edge, this edge, this edge and this edge. I will create a face. If you see, this is color is changed, which is in cyan color. So if I shade it, you will see that okay, there is a face created. So again I will go to wireframe. Now I can always create a vertex on a face. So I will go create vertex on a face. As we have seen, edge has only one direction, which is u. Face has two directions, one is u and other is v. So what I need to give is, I need to give what is the value of u and what is the value of v, and it will calculate the xyz coordinates of that vertex which is going to be created. So the procedure is, go to pick mode, select the face, keep on pressing that particular right click or middle click, and then drag your vertex at particular location. Whenever you are going to drag, if you have a look at the form, the value will be changed here, u value and v value will be changed. So right click will create a vertex. So this vertex is again created on the face, but it is not part of a face. It means it is nothing to do with the face after creation. Only thing is, while creation of this vertex, what it has used is, it has used this face definition, and it makes sure that that vertex is lying on the face. It means if it is a curved face, definitely the vertex will be on the face itself, or if it is a planar face, it will be on the face. In the sense like xyz will be exactly on the face. It has used this face definition only for creating this vertex. Once the vertex is created, it has its own definition, it has its own xyz coordinates. So this is a real vertex, and that is a standalone vertex. If you see, that is why it is in white color. Now similarly, I can go and say virtual vertex. Again I will go to pick mode, select the face, drag the vertex at particular location and just say apply. Once you say apply, if you see, the color of this is different than color of this. This is a virtual vertex. Now this is something to do with the face. It means this is relying on this face for its definition. It don't have its own definition. So I cannot delete this face if I unless and until I delete this particular vertex. So that is the concept behind real and virtual vertex. Virtual vertex doesn't have its definition, real vertex has its definition, and virtual vertex needs the host. So create vertex on a face, host will be a face. So this is the way you can create vertex on a face. This is important if you want to create some geometry on a face and then or edge on a face and then extrude that face, something like that. We'll see those higher order operations, higher topological operations later. So this is nothing but create vertex on a face. You select the face, you say real or virtual type, you give UV value, or you can also give XYZ coordinate and then just say apply. The next method is on volume. This is always a virtual vertex on a volume. So if you have any volume, let me create one volume, let me create a brick. So I got the brick. So the vertex on a volume, again this is again a virtual vertex. If I select this volume and then if I say apply, if you see vertex is created at the center of this, or if I say okay on volume, and if I give some coordinates like let's say 5, 5, 5, 5, apply. If you see the vertex is created on this, there are a lot of things, so I'll just delete everything, say reset, then I'll create a cube, fit to screen, then on volume. So I can select this volume. If you see by default it creates the vertex at 0, 0, 0, which is nothing but the centroid of the volume. I can say apply. If you see the color of that is always in virtual entity, or I can say okay select this volume and then give a value like 5, 5, 5. If I say apply, if the vertex is created here, this is a virtual vertex. It means if I go and ask this vertex who are you, it always says that I am a virtual vertex which relies on this volume for my definition and I am this much away from the centroid. So that is what this virtual vertex has. So sometimes we can use this virtual sometimes we can use this virtual vertex for some other operations. So this is virtual vertex on a volume. So it can be within the volume or it can be outside the volume. For example, I can always say 10, 10, 10. If you see this vertex is outside the volume, but always it has a reference to the centroid of this volume, and again the funda is same. I cannot delete this volume unless and until I delete this particular vertex. Fine. So this is nothing but create a virtual vertex on a face. This is nothing but create virtual vertex at the intersection. If I have edge, if I have any edge, for example I will create a edge. So first is I will create the vertex on edge. So for example let's take this face. So I will create this vertex, 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 then I will create the edges. Let's say this vertex and this vertex one edge, this vertex and this vertex another edge. So this is nothing but create vertex. These are the two edges which are intersecting at this point, let's say. Now if I go and say create vertex at the intersection, what it will ask is, it will ask you edge 1 and edge 2. So I will select edge 1, I will select I will select edge 1. Let's say this is the edge 1, this is the edge 2. It will create a vertex at the intersection. If you see, you got the vertex at the intersection. Now there are different methods, or there are different cases of creating vertices at the intersection. Let's have a look at all those operations. So this is create real vertex by giving the coordinates. These are the commands associated with that. It means if you want to write a journal file which will do all the operations automatically, so this is the command we should use. This is the syntax of the command, and this is one sample command which is vertex create coordinate 15 2.3, something like that. So this is nothing but a command associated with create real vertex. This is again create vertex on an edge, real or virtual on edge. You can activate real and virtual. So pick the edge. In list box you can specify what is the value of u, or you can specify the value of u by mouse click. So this is nothing but location with respect to the start point of the edge, and it will create give the coordinates, or you can also provide the coordinates. It will calculate u, or you give u, it will calculate the coordinates. So this is the way the vertex will be created on the edge. This is command associated with that. This is the syntax of the command, and this is sample command. Vertex create on edge dot 6 upper parameter or u parameter is equal to 0.5. This is the command associated with vertex creation. Similarly, you can create vertex on the face, create a real or virtual vertex on an existing face. So you have to activate real or virtual. You give u value, v value, you will get the vertex on the face. So this is the command associated with that, useful to create an edge on the surface for use in a virtual split operation. Why it is useful? Because if you want to split the face into two faces by using a virtual edge, so first thing is you have to create a vertex on a face, and then you create an edge out of it, and you use that edge for a split operation. This is create virtual vertex on a volume. It creates a virtual vertex associated with the existing volume. The default position is the center of the volume. To reposition, enter the coordinate of the vertex. So you enter the coordinates here, it will reposition it to some other location, and definitely that location need not to lie within the volume. It can be outside the volume. So does not snap to the point of the volume if the coordinates are outside the volume. It will create it at that location only which you have given. This is the command associated with that. This is create vertex at the edge intersection. There are different you can say scenarios which can happen. One is like you have only two edges and they are intersecting only at one point. That is one case. Or you have two edges like curved edges, they are intersecting at multiple points. The third case is you have two edges which are not intersecting but they are approaching for intersection. And the fourth case is again you have two edges and there are possibilities of having multiple intersections. So these are the four cases in which the vertex can be created at the intersection. So we will have a look at all those four cases. So what this operation does, the basic function of it is it creates real or virtual vertices at the point of intersection, or it says that it is creating it at a closest approach between any two edges specified, and definitely they are not topologically connected to each of the edges. It means it will use the intersection point only to calculate xyz coordinates. Once the xyz coordinates are calculated, the vertex will be created and that will be a standalone vertex. It will not be a part of the edge. That is what is mean by not topologically connected to either of the edge. If the edges are intersecting, the vertices are created at each intersection. It means if there are two edges, if they are intersecting at one point, only one vertex will be created. If they are intersecting at multiple points, multiple vertices will be created at each intersection. This is the case where two edges are intersecting with each other. If the edges are approaching to each other for intersection, it means they are not intersecting but they are just approaching for intersection. In that case, the vertex is created at the closest approach. It is not created at the each and every possible intersection, but it creates the vertex at the closest approach. But in the first case where they are intersecting to each other, the vertex will be created at each intersection. If the intersection or approach is near the end point, then something else will be done. If the end point of the edge 2 lies near the body of the edge 1, it is created or it is not created. We will have a look at all these cases. For example, this is the case. In this case, let us say this is the edge 1, this is the edge 2. It means that this is the first edge selected, this is the second edge selected. Now if you see, they are not intersecting to each other. If you have a look at it, they are not intersecting to each other. They are not intersecting to each other. There is a gap here. They are approaching for intersection. Now if you give this edge as the first edge in the form, if you give this as edge as this first edge as the first edge in the form, and this is the second edge, the vertex will be created, because the rule is if the end point of the edge 2 lies near the body of the edge 1, it is created. It means as the end point of the second edge selected is near the body of the first edge, definitely the intersection vertex is created. But if in this case it is not created, because this is the first edge that you have selected, this is the second edge that you have selected. So the end point of this edge 2 is not near the body of this edge 1, so vertex is not created. So this is some rule that we have to take care while giving these edges for intersection. create vertices at the edge intersection. There is something called as tolerance. Tolerance will take care if there is a gap in between. For edges which do not exactly intersect, what we can do is we can just make Gambit to say that okay, it is intersecting by giving the tolerance value. There are two methods. One is auto tolerance. Gambit automatically computes the tolerance based on the internal algorithm, and it decides whether the vertex need to be created or not. Or you can give the manual tolerance. The tolerance is nothing but if the edges are there which are not intersecting, there is some gap in between. So what you can do is you can create the vertex by providing the tolerance which will be more than the gap which is in between. So that is the use of tolerance. So this is the you can say a form, vertex creation at the intersection form. So you have to select the first edge, you have to select the second edge, then you have to provide the tolerance if they are not intersecting. You can also create a virtual vertex at the intersection by activating this virtual operation. So let's have a look at the different scenarios which we have discussed. This is first, it means you have the edges which are perfectly intersecting with each other and there is only one intersection point. So in this case what you can do is you can create the vertex at this particular intersection. So this is the first case. Now let's create some another you can say geometries. So let me create the vertices very fast. Go to tools, and this is nothing but a grid. I will explain this. Update list, go to update list again, then say apply. So you got a graph paper, you can control click and create the vertex. Control right click, you create the vertex again. For example, okay, let me create the straight edge here, and then let me create a curved edge, probably something like this. This is one, and let's say I want to create one more edge, or let's do this first. Apply, make these things invisible, go to edges, geometry edges, and create a straight edge first, which is nothing but this. I'll create the straight edge and then create a curved edge or nerves. Let's say this point, this point, this point, this point, and this point. So I got a nerves. Now if you have a look at this particular case, both are in same plane, so definitely they are intersecting with each other, and there are multiple intersection points. So this is one intersection point, second intersection point, third and fourth intersection point. Now if I say create vertex at intersection, if I select, let's say this is the first edge and this is the second edge, and if I select apply, if you see vertex is created at every intersection. This is 1, 2, 3 and 4. It is created at every intersection, correct? Now let me go and move this edge at some different location. So for timing, let me move this edge to some other location. Go to edge, general operation, move copy operation. So I will move this particular edge, let's say in y direction by minus for example 5, correct? So now if you see, these two edges are not intersecting to each other, but if you see they are approaching for intersection. So I can definitely create the vertex, I guess, at the intersection. So go to intersection, let's say this is the first edge and this is the second edge. No intersection was found. Okay, fine. So go to edge, I'll say mirror, move copy, reflect operation, this edge, and the reflection plane should be y, exit plane. So define the plane, the normal should be positive y, apply, and then apply, correct? So I have reflected this. Now I guess they are approaching for intersection. So I will say this is the first edge and this is the second edge. If I extrapolate this, correct, good. So in this case what happens is, like if you see these two edges are not intersecting to each other exactly, there is a gap. So we can always control that gap. For example, I can say okay, this is the edge, this is the first edge, and this is the second edge. I can say the gap between these two is 5. I will say apply. If you see one vertex is created here, it has calculated this as the intersection point. It will definitely not do this extrapolation. It will always say that this point, and it has also calculated this point. It means you just take this particular edge in upward direction and make sure that they are intersecting. So in that case, wherever the vertex will be created, it will create the same vertices. In the sense, imagine that you are moving this edge in upward direction so that this is intersecting with this edge, so it will create vertex here and vertex here. So same case we have done by giving this tolerance value. So this is the use of tolerance, and this is the use non-intersecting edges. So this is what the vertex creation at the intersection is. So the funda is again, if the two edges are intersecting with each other, the vertices will be created at the intersection. If the two edges are not intersecting, the vertex will be created at the closest intersection. And you can always control the gap. If the two edges are there, if there is a gap in between these two edges, you can always control it by giving this tolerance value, or you can say virtual or real if you want to create virtual real vertices. So this is about creating vertices at the intersection. This is nothing but create vertex at centroid. So let's say reset, let me create a volume again, brick. This is very important, you can say a tool available in Gambit. If you want to create a vertex at the centroid of some entity, so I can the entities could be volume. So I will say this, apply. If you see, the vertex is created at the centroid of the volume. The entity could be the face. So here I will go and say okay, face. So select a face and then select any face that you want, let's say this face, and say apply. The vertex is created at the centroid of the face. Or you can say okay, I want to create a vertex at the centroid of the edge. So select the edge, say apply. The vertex is created at the center of the edge. So this is the important operation, in the sense, if I want to create a circle which is exactly at the center of this face, so I will create the center point, then I will copy it here and here, and then I will create circle, and then I will sweep that circle. So that is the operation of creating vertex at the centroid. The last operation is nothing but project vertex. It means if I have one vertex, for example, if I have this vertex, if I want to project this vertex on this particular edge, I can always do that. So select the vertex you want to project and the edge on which you want to project the vertex, say apply. The new vertex is created. You can always select more than one vertices. For example, I can always say that okay, this vertex and this vertex, project it on this edge. So if you see, we got one vertex here and one vertex here, so it is nothing but project vertex. At the time of projection, you can always specify that I want to split the edge. So if I say again this vertex and this edge and split this edge, if I say apply, if you see, this vertex has, the color of this vertex is green, it means it is a part of this particular edge. So what it does, this projects the vertex, it creates the new vertex. It uses this vertex as a split tool, and it splits this particular edge, and that edge is a part of a volume. So definitely this will be in a green color, because the higher order topological entity color of that is green. So this is the summary of all the operations available in Gambit for vertex creation. One is you give the coordinates, xyz coordinates, it will create the vertex at those. Other is you give on the edge, or third is you give on the face, on volume, at intersection, at centroid, and project vertex on a edge. So these are the different methods by which you can create vertices. There are other methods also which we will have a look at it, like how you can write it in a text file and import it. So what we had a look at is the different vertex create operations. Now let's have a look at other operations which are there on vertices. Another way of creating vertex, which is very important, is if you write the vertices in a particular way in one particular text file, you can actually create vertices. So if you go, that operation is nothing but create vertex by importing data from the file. So if you go to file, import vertex data, and then I have created one vertex one file which I'll show you. So I'm just browsing the file which is necessary for vertex creation. Then Gambit, specific lectures, filter. Now I'll just use a file, let's say pressure site.txt. Accept. Say accept. You see it is creating vertices. So what I have done is import, let's say vertex data, and if you have a look at the particular file, I'll say again reset file, import ICM input. I'll browse the file. The file is a text file, so I'll say filter, and the text file is pressure side. Accept. Now I want to create vertices as well as edges. I don't want to create a face out of it, so I will say accept. So browse, the file is pressure side.txt. Accept vertices and edges, and if you see what I got is the edge. So how it works is, if I will just browse that particular file, lectures, PPT, software training, Gambit, CCTech lectures, and then let's say pressure side. So I'm opening that pressure side file. So this is the typical format for ICM input. These are the number of points, number of vertices, and the number of curves that you want to create using vertices, and then XYZ coordinate of those vertices. So this is the data. Now what Gambit does is, Gambit takes that data and creates the particular entity. So let's have a look at the operation ICM input. So this is the typical format of the file that you have to give. NPC is nothing but number of points, NC is nothing but number of curves, and XYZ coordinates. Now once you have written this in a particular form, which is this form, then you can create the edges, you can create vertices, you can create edges out of vertices, and you can create face also out of edges. So what you have to do is, you have to browse the file in which you have to keep the information in a proper way. Then you can activate, okay, do you want to create vertices, do you want to create edges, and do you want to create a faces out of it. So in this case, the file which we have used, in this case, if you see, I want to create, let's say this is the airfoil data, in which one is pressure side and other is suction side airfoil. In that I have 46 vertices, and I want to create only a top side of the airfoil. So there are 46 vertices which are given. So number of points 46 and number of curve is 1, and I am going to create the curve by using this operation. So I will say file, import ICM input, browse the typical file, and then say accept. So this is the typical geometry which is created. These are the 46 vertices, and one edge is created out of it. Similarly, I will browse another file which is suction side, import ICM input, browse. So I will say suction side, accept. I want to create vertices and edges only. I will say accept. If you see, one more edge is created, so I got the airfoil data. And now if you see, the first vertex and the last vertex of that particular list will be only a part of edge. Remaining vertices are just created or used to create the curve, and this curve is actually a nerves curve. So I can go and delete all the vertices. So it will delete only the unattached vertices. Attached vertices will not be deleted. So I got the airfoil data. Similarly, what you can do is, if you don't want to create the edges or faces. Like I can always create a face out of it. For example, I can go and create a wireframe face. So I got a wireframe. So this operation can also be done at the time of importing ICM input. So if you go to ICM input, you can always activate face, what kind of face that you want to create. There are different type of faces. We will see this in face creation operation. So you can also activate this. So this is another way of taking vertices in Gambit. The next method is only vertex data. In this particular file, what you do is you just put the vertex data in typical format. In this case, I am not going to put this to the value like how many number of vertices, and I am just putting XYZ coordinates of the vertices which I want to create. So I will say browse and pressure side accept and accept. If you see, you get only vertices, you don't get edges and all, because that is not there in that function vertex data. So file import vertex data is nothing but you have some vertices which are kept in one text file XYZ coordinates. You can create vertices by using this particular option. The another way of creating vertices in Gambit is, I guess we have seen that couple of times, which is nothing but creating a grid. So this is nothing but, okay, you want to create a grid in which plane. Let's say I want to create it in XY plane. The minimum should be -10, maximum should be 10, and increment should be 1. Update list, similarly Y update, and say visibility on. So what you got is, you got a plane. Now you can say control and right click to create the vertex. So this is another method of creating vertex in Gambit. So this is all about vertex creation operation in Gambit. Now let's have a look at some other operations. Like as I said, I import ICM input. ICM data consists of set of coordinates that defines point in a space. You can specify the special point directly to vertex, create a set of edges, and it means using vertices, create edges, create faces. So there is one option called as tolerance in ICM input, specifies the maximum allowable distance between the created Gambit geometry and the original ICM input data. It means if you have given vertices, how much distance that you are allowing between the vertex and the edge which is going to be created. So this is the options, is specifying the geometry to create. If you activate vertices, it will create vertices. If you activate edges, it will create the edges. If you activate faces, it will create the faces. And these are the face creation operations, different ways, and this is the typical form for ICM input. Similarly, you can import the vertex data. The sample file is like, you just give XYZ and browse that file and accept. It will create the vertices at that particular location. This is one operation which is virtual operation again, which will allow us to slide a virtual vertex on an edge. I guess we have seen this in vertex, you can say virtual operations, where whatever the vertices or whatever the geometries which I am going to create, that geometry I can modify if that is a virtual geometry. So I'll say reset, I'll create one face, for example, let's say 10 by 10 face, and then I will create one vertex on edge, let's say a virtual vertex on this edge, and on this edge also I will create a edge, straight edge, by using these two vertices. Virtual by using these two vertices, there is no host, apply. Then I am going to split this face using this edge. So this face, edge virtual, this edge. So I got two faces. Now what I am going to do is, for example, I am going to mesh this particular face with some mesh and mesh this. Now I can actually use a slide virtual vertex operation. Go to vertex, and this is slide virtual vertex. I can actually slide the vertex. So just select this vertex and just slide it some other location, middle click and drag it, slide, and just say apply. If you see, everything is changing. It means all the higher order topological entities are changing. This edge definition is also changing, the face definition is also changing, and the mesh is also changing on it. So that is the use of slide virtual vertex. This connect operation connects the edges. It means if I create again some points, let's say this is point 1, point 2, and then point 3 and point 4, and let me create edges, this vertex and this vertex. Sorry, I want to create real edge, so this vertex and this vertex and this vertex and this vertex. So if you see, right now they are not connected to each other, they are not sharing a common vertex, and there is a large gap in between, so I can go and connect them. So edges are connected using vertices, so I will say virtual forced, and I will select this vertex and this vertex, so they are connected. So this is the use of connect operation. It will connect the two edges. If there is a gap, you can use virtual. If there is no gap, it means if they are in the proximity of 10 raised to minus 6, you can use real. We have seen this in general operation. Similarly, the disconnect operation is nothing but it will disconnect the entities. It will disconnect two edges, and it will create the copies of the vertices, and we have also seen this operation in general operations. So this is the, you can modify the label of particular vertex, you can modify the label of this vertex to, let's say, a start or something like that. You can modify the label of this vertex. You can also modify the color of the vertex. You can also modify the color of the vertex. This is a move, copy and align operations. We have seen that in general operation. This is a convert operation which will convert a virtual vertex into a real vertex, which will convert virtual vertex into real vertex. This is summary. It gives you the coordinate of the vertices, what is the coordinate of the vertices, coordinate system, and it is connected to which edge. For example, this vertex, if you talk about, this is connected to two edges, so it is common between these two. Some summary can give a lot of information. Check is nothing but it will do a checking, geometrical checking, as well as the topological checking. So it will give that, okay, if there is some problem in the geometry, you can rectify that problem. We'll see what exactly the checking does and all. Then query is nothing but you can identify the label of the vertices, and this is just to correlate between the entity name and the entity itself. So this is nothing but query, and total will give you the total number of entities in the transcript window, the total number of entities in the transcript window. This delete operation helps to delete the vertices. If I say delete all, right now nothing is there, but it will delete all the unconnected vertices. Right now I cannot delete these vertices because they are connected to the edges. So if I go and delete these edges, there are vertices, so I can delete the vertices. I will say all, apply. If you see, only one vertex is deleted because these two are part of the edge, so you can delete vertices by using this particular operation. This is all about vertex operations in Gambit. In next lecture we are going to have a look at the edge operations in Gambit. Thank you.